Most LED installations that failed prematurely didn't start out wrong. They started out acceptable, so in the beginning it looked good unless there was obviously a fault, and then it slowly degraded or degraded quickly over time. And there's so many reasons. Sometimes it's idiopathic or just random and you just don't know what happened, and it usually boils down to product detail. So they've passed commissioning, they've looked good at handover, and they met spec on paper. But the problem is that the LED's performance isn't time dependent, and many of the decisions that affect longevity are locked in before the installation or before the fixture is even mounted. What makes LED linear lighting very different from traditional electrical work is that the degradation is gradual and visible at first, and then all of a sudden it goes bad. There's heat stress, there's optical mismatch, there's mechanical strain, and electrical overloading that don't show up immediately. So let me talk about optical mismatch. I mean, it's not just the optics of how the light behaves over time. It's really the materials that are used. They could get yellow, they could age. So you see those panel lights that there's this frosted glass over it. That could degrade. Your LED light source could be working fine, but that could turn yellow over time and really change the whole environment and how the light performs and behaves. They could easily show up after months or years later as color shift starts to happen, or there's uneven output, or flickering, or driver distress, or there's just an outright failure. Hopefully, the product is under warranty and you can get a replacement. But this usually happens long after the decisions are made on what LED is selected. So, this lesson is really about reframing success. It works now is not the same as it ages well. It's going to work well later down the line. So, LED linear lighting doesn't usually fail because of one bad component. It really fails because of early decisions that quietly compound over time. Think about the last LED installation you completed and answer these honestly. Did it look good immediately after install? Would you confidently say it would look the same in 2 or 3 years? And were any decisions made based on any rule of thumbs, such as we've always done it this way, we use the manufacturer's specs alone? Just note your answers. It's just something to think about. So, I'm going to give you a small framework, as I mentioned in the previous intro video. The three main reasons why installs age poorly: the application, there's a mismatch in the application, where the product is being used, how it's being used, the environmental strains that are present in the space, the stress decisions such as the brightness, heat, loading, and their hidden constraints such as control parameters, design details, engineering limits. You don't need to understand these yet, just recognize them as time exposes them. We've seen installs where the product was right, the installation was clean, and the spec was followed, yet the lighting aged badly because the application reality didn't match the assumptions. Nothing was wrong on day one. The problem only became obvious later when fixes were expensive and sometimes even impossible because you had to rewire and open up ceilings. That's why longevity must be evaluated before installation, not after.